In our 6.13 notes, we're going to be talking about the properties of parallelograms. So you'll see that we have a diagram at the top that starts with quadrilateral. A quadrilateral is a four-sided figure. And there are a lot of shapes that fall underneath this, but we're going to be focusing on parallelograms and rectangles. You'll notice that parallelogram is above rectangle, meaning a parallelogram can be a rectangle, but a rectangle cannot be a parallelogram. And we'll talk more about that in just a moment. Let's first move down to our properties and discuss what makes something a parallelogram, what makes something a rectangle. So a parallelogram is defined as a quadrilateral, again, which is a four-sided figure, in which both pairs of opposite sides are parallel. So this side is parallel to this side, and this side is parallel to this side. Opposite sides are also congruent. So not only are they parallel, but this is an equal distance to this, and this side has an equal length to this side. Opposite angles are also congruent. So angle B is congruent to angle D, and angle A is congruent to angle C. And diagonals bisect each other. We learned that bisect means to cut in half. So that means that if this diagonal bisects this diagonal, and this diagonal, they bisect one another, we can say that this line segment is congruent to this line segment because it's being cut in half at O. And therefore this line segment is congruent to that line segment, again, because it's being cut in half at O. We're now going to talk about rectangles. So again, a rectangle is a parallelogram, but a parallelogram is not a rectangle. So let's figure out what is the difference between these two. So a rectangle is defined as a parallelogram with four congruent angles. This is one of the major differences. Instead of having just opposite angles be congruent, every single angle is the same. So they're all congruent to each other. We also know that in a rectangle, if this is the case, all of the angles have to be a right angle. That is because in four-sided figures, there are 360 degrees. Just like a triangle has 180 degrees, a quadrilateral has 360 degrees. So if we were to break 360 into four equal parts, (360) divided evenly by four angles means that each angle has to be 90 degrees. So a parallelogram with four congruent as well as right angles. A rectangle is also a quadrilateral in which both pairs of opposite sides are parallel, just like a parallelogram. So this side is parallel to this side, and these two sides are also parallel. Opposite sides are congruent, same as before. This is congruent to this is congruent to that. Opposite angles are congruent, obviously, but all angles are also congruent. And the diagonals, again, bisect each other. We're going to add a sixth one in here that I did not include and say that diagonals are also congruent. Meaning the length of this diagonal is congruent to the length of this. But because they bisect each other, we can also say that the line segments that are created by being bisected or cut in half, these line segments are also the same length, right? Because this is being cut in half here. So this is congruent to this, and so is this line segment.